Okay, questions from last night's homework. Do we have any? Keegan, number one. So today, page 59, Rational Exponents, Part 2. The objectives for today will be the same as yesterday. So go ahead and turn on to page 59, and we'll start our notes. So at the top, page 59, Rational Exponents, Part 2. So Rational Exponents Part 2. Today we're going to start by making a table that we can use to move back and forth between radical and fraction-based problems. So at the top, go ahead and put radical. A line with 3 lines available, and then fraction. So under radical, when we're converting from radical to fraction, the radicand, or the number under the radical sign, or inside the radical, what does that become when it is a fractional expression? The whole number, or what's another general term? It could be a variable, right? So what's that? What do we term or base? So the base of the expression. So radicand becomes the base. So here we have a radical, and our radicand is 9. Over here we have a base, and it's 9. So radicand becomes base, vice versa, base becomes radicand. So these go both ways. So next we're going to take a look at what the index becomes. The index, what does the index become? The denominator of the fractional exponent. So the index becomes the denominator, and the denominator the index. So here our index, and then we have our fraction denominator. Today, this is going to be the new portion. The exponent of the radicand, or the radical, what does that become? The numerator. And vice versa. So the exponent becomes the numerator, and the numerator becomes the exponent. So this is a chart that you can use to transform between radical and fractional, radical problems and fractional problems easily, and you get the method. So let's take a look at a couple examples, and today we're going to work on solving them. So we have examples. Let's start with the cubed root of 27 x to the 6th. So we have the cubed root of 27 x to the 6th. So how are we going to translate this to fractional? The 6 is just with the x. Angelina? So we have 27 x to the 6th to the 1/3 power? To the 1/3 power. So now we have a power with power. So recalling from pre-algebra, start of this semester, from yesterday, what do we do with powers of powers? So we multiply them. So it gets distributed to both the 27 and the x to the 6th. So we have 27 to the 1/3 power and x to the 6 over 3, because 6 times 1/3 is 6 over 3, right? 2x or what? X squared. No. So we have 27 to the 1/3 power, and as Angelina said, x squared. So what is 27 to the 1/3 power? Parker? 3. If we didn't know that, we can use our calculators and put 27 and then use that caret. So everybody get your calculators out. So we type 27 in, and then we press this caret button, or this up arrow, and that gives us our exponent, and then we can go ahead and push ND, and right now our exponent is 1/3. So 27 to the 1/3 power, as Parker said, is 3. So I only want you to use this after you've transformed it from one to the other, and when you're going to solve it. I want you to transform it, and then you can use this to solve. So I need to see the transformation in your homework before you solve. You can, and this is how you would solve a problem that has a fractional exponent. So you're going to use the caret, then the ND button, and then whatever the fraction will be. So now we have 3x squared. What if we had another example of x to the 1/3 to the 6th power multiplied by the 4th root of y to the 4th? So when you're working with variables, it's a lot easier to see how it would simplify when it's in the fractional method, right? So there's no, you don't have to change this to the radical version. Just change this one to the fractional version, because it's very easy to see that you can just distribute that 6 and multiply 6 over 3 and get your x squared, right? So we're going to go ahead and leave that the same. Now let's transform the 4th root of y to the 4th. Angelina? So we have y to the fourth, in parentheses, raised to the 1/4 power. Now we have powers that have powers, so we're going to do what? Powers have powers. We're going to multiply. So we have x to the 6/3 and y to the 4/4. And x to the 6/3 leaves us with x squared, and y to the 4/4 leaves us with y. So when working with these types of problems, when it's just, or anytime you have a variable in the problem, it's a lot easier to see how to work through it when it's in the fractional method, right? Can you notice that this is the fourth root and this is to the 4th power, and those might cancel out? Yes, but if you don't see that, or if it's a fraction, or it's numbers that don't work out perfectly and cancel each other out, change it to this method and then use the power of power rule and simplify from there. So let's try another example. Let's say we had z to the 1/3 power cubed over the square root of z squared. So we have z to the 1/3 power cubed and the square root of z squared. So we're going to go ahead and solve this and then use our pre-algebra rules of dividing exponents. So z to the 1/3 cubed, what does that simplify to? Z to the 3/3. Here we have z, the square root of z squared, which is z squared to the 1/2. So z to the 3/3 is z to the 1st. And then we have z to the 2/2, right? Which is also z to the 1st. And anytime you have, well, what's our answer? We have z over z equals 1. Some of them are. Maybe. There are problems that look exactly like them on your homework. You'll have a lot of time in class to work on them. Let's try another one. Let's say we have 4 to the 3/2 power. So we have 4 to the 3/2 power. How can we change this? Corbin?
Square root of 4 in parentheses to the 3rd power.
The square root of 4, parentheses to the 3rd power, and our index is 2. So what's the square root of 4? Square root of 4 equals 2. 2 cubed is 8. So this is building off what we did yesterday. Now we're solving problems, and we're also going to have numbers that are not 1 in the numerator of the fractional exponents. So let's try 27 to the 2/3 power. How can we change this to a radical? Sam? How can we change this one to the 2/3 or to a radical? So 27 is the radicand. Index is 3. So do we know the cubed root of 27? Cube root of 27 is 3. And 3 squared is? How about if we had 256 to the 3/4 power? (256 to the 3/4). How can we change that? Keegan? So off the top of our heads, do we know what the 4th root of 256 is without using our calculators? So, if we don't know the 4th root of 256, what can we do? We can go to our calculators, put 256 in, use our caret, use our caret to the 1/4 power. That's the 4th root of 256, right? That gives us 4. So now we have 4 to the 3rd power, and that equals, we can use our calculators for that. 16 times 4? Yes.
Can we just divide 256 by 4? Is the same answer?
That's just a coincidence. Coincidence. We cannot divide exponents. We cannot use our exponents to divide the number. It just happened to work out that way sometimes. We have to make sure that we change it to this and use our steps. So 4 to the 3rd power is 64. Let's say we had 64 to the 5/6. How do we translate 64 to the 5/6? Sam? 64 is a radicand. 6 is the index. And 5 is the exponent. So using our calculators, we probably don't know what the 6th root of 64 is off the top of our head. So we have 64 raised to the 1/6 power. That gives us 2. And then we have 2 to the 5th power, which equals 32. How did we get 1/6? So, side work. We had 64 to the 5/6 power, right? Yeah. If we were to break this apart into 2 different fractions, or 2 different 5/6 into 2 different fractions, what would that be? That'd be 1/6 times 5, right? So this is our exponent, which is this is our numerator, which is our exponent, and this is our index and our denominator. So this is the 1/6 power. Does that clear that up? Let's try one more and then we can get started on our homeworks.
Is that notebook college rule or white rule that you're using?
It's wide rule.
Okay, just kind of figured because I don't have half page. Oh yeah.
Yeah. One more. We have 1,000 or 100 to the 3/2. What does that equal? Somebody new.
I'll just answer myself. Grace. Pick Grace. Oh, never mind. Don't pick Grace.
We won't pick Grace.
Pick
Valencia? What is that term called right here? The radicand. Index is 2. Three. So the square root of 100 is 10. And 10 cubed is
1,000. You answered the question when you tried to give it to us.
it happens. Okay.
I got my answer and I just started laughing.
So today we're going to talk about experimental probability. So today we're talking about experimental probability on page 42. Once we've got that written down, flip on over to page 36 for our objectives. Page 36, our objectives. So find experimental probability.